Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules.
Welcome to Lesson 18, 4 interesting transformations of functions. Starting with a classwork example, it says to let f of x equal the absolute value of x, g of x is f of x minus 3, and h of x is f of x plus 2, where x can be any real number. Write the formula for g of x in terms of the absolute value of x. In other words, without using f of x notation. So what we're doing is we're taking f of x minus 3, which is g of x, and substituting it in for here. So it's f of x minus 3. Well, x goes into the absolute value bracket, so g of x is simply going to be the absolute value of this x minus 3 in that absolute value bracket. So g of x is the absolute value of x minus 3. Okay, and then h of x is f of x plus 2. So we're going to take that x plus 2, we're going to plug it in for x in the f of x, which therefore puts it in the absolute value bracket. So we're going to get h of x equals the absolute value of x plus 2. And there you have it. So now we have a table, then they want us to complete the table for these three functions. So the absolute value of x is the first one. F of x is the absolute value of x. Here are our x's. So we're just taking the absolute value of these numbers. And the absolute value of negative 3 is 3. Absolute value of negative 2. Absolute value of negative 1. Absolute value of 0. Absolute value of 1. Absolute value of 2. Absolute value of 3. Okay, that was easy. And now g of x, we're just going to do the absolute value of x minus 3. We're going to subtract 3 from all of these and then take their absolute value. So let me just put that in first. So negative 3 minus 3 is negative 6. The absolute value of negative 6 is 6. Negative 2 minus 3 is negative 5, and the absolute value. Negative 1 minus 3 is negative 4. Absolute value is 4. 0 minus 3 is negative 3, absolute value of negative 3 is 3. 1 minus 3 is negative 2, and the absolute value is 2. 2 minus 3 is negative 1, absolute value of negative 1 is 1. And 3 minus 3 is 0, the absolute value of 0 is 0. So then I'm going to erase all of these. And now we're going to do the last function in green, h of x, which is x plus 2. So here's our x. We're just going to add 2 to all of these. So let me just write these in here first. And then we're going to take their absolute values after adding 2. Negative 3 plus 2 is negative 1. Absolute value is 1. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. Absolute value is 1. 0 plus 2 is 2. Absolute value is 2. 1 plus 2 is 3. And the absolute value is 3. 2 plus 2, 4. Absolute value of 4 is 4. 3 plus 2 is 5. And the absolute value of 5 is 5. Let's see. Okay, page 2 brings us to part D. Graph all three of those equations. So I brought in a table with all those values, and we're going to graph f of x first, and I'll do that in red. F of x equals the absolute value of x, so we're just plotting these points as points like so. Negative 3, comma 3. Left 3, up 3, put a dot. Left 2, up 2. Left 1, up 1. 0, 0 is our origin. 1, 1, 2, 2, and 3, 3 go just like this. Then I take a line segment, let's make it thin and red, and we go like so, and we go like so. Okay, so there is the absolute value of x, and that is f of x. Okay. And we're going to just say that y equals f of x. All right, now I'm going to graph g of x. So let's erase this. Okay, so in order to graph g of x, let me use blue. So g of x is f of x minus 3. So I thought I switched to blue. Okay, here we go. So this is our x. Ignore this column now. And this is our y. X, y, x, y, x, y. Negative 3, 6. Negative 3, 6. Negative 2, 5. Negative 1, 4. 0, 3. 1, 2. 2, 1, 3, 0. Okay, so I'm going to point something out here in a minute and explain what happened. So here is the graph of those points. Okay, that looks like a linear function. There's no v. So this table does not take into consideration points on both sides of the vertex. And the vertex is whenever this is 0. So what makes this function 0? Well, when x is 3. 3 minus 3 is 0. So there's our vertex right there. So we need points on the other side. So if I put 4 here, 4 minus 3 is 1. The absolute value of 1 is 1. So we'd get to the point 4, 1. So I'd be right here. And if I chose 5, 5 minus 3 is 2. The absolute value of 2 is 2. So we'd have the point 5, 2. So now you can see what's happening on the other side of the vertex, and we can finish this graph. And so it goes like this. All right, and finish that, and I'm going to call that y equals g, or not, I'm not going to call it g of x, I'm going to call it f of x, and put the transformation in. F of x minus 3. So there's our f of x minus 3, or our g of x. Okay, so keep in mind when you're doing absolute value functions, you absolutely have to have values on both sides of the vertex to see the v shape. Okay, so now we're going to do h of x. So ignore these and ignore these, and this is our x and this is our y, and we're going to do h of x equals f of x plus 2, and our first point is negative 3 comma 1. So negative 3, 1 is here, negative 2, 0 is here, negative 1, 1 is here, 0, 2 is right here, 1, 3, 2, 4, and 3, 5. So this one gave us 1 point on the other side of the vertex. So if we wanted to go a little further and say, well, what's going on at negative 4? Well, negative 4 plus 2 is negative 2, and the absolute value of negative 2 is 2, so negative 4 up 2. So you do see this is continuing that way. So we can draw a segment. Yeah, let's use that. So this is going like so, and this is going like so. And then I put arrows at the end like this, and this is y equals f of x plus 2. Okay, so there are our 3 functions, the red one being the parent function, the blue one, x minus 3, is shifted right 3, and the green one, x plus 2, is shifted left 2. Okay, so let me clean this up and move on. All right, so E says, how does the graph of y equals f of x relate to the graph of y equals f of x minus 3? The graph of y equals f of x minus 3, which is the blue one, relate to the graph of, is the graph of y equals f of x translated horizontally to the right 3 units. So I want to point something out to you here. Transformed to the right 3. Well, look at what the function is saying. X minus 3. It's in parentheses, so we always do the opposite direction, because you have to think to yourself, what makes this 0? Positive 3 makes x minus 3 0, so it's a shift right 3, because what we substitute in is positive 3. That's why it's opposite. Okay, F. How does the graph of y equals f of x relate to the graph of y equals f of x plus 2? All right, the graph of y equals f of x plus 2 is the graph of y equals f of x. So f of x plus 2 is the green one. It's the same as y equals f of x, the red one, except it's shifted left 2. And the reason it's shifted left 2 is because the reason it shifted left 2 is because we put a negative 2 in here to make this 0. Negative 2 plus 2 is 0, and that gives us our 0 or our vertex. So the negative 2 is a left shift of 2. Okay, G says, how do the graphs of y equals the absolute value of x with minus 3 on the outside and y equals the absolute value of x minus 3 inside relate differently to the graph of y equals the absolute value of x? Okay, to show you the difference between these two, I've decided to get the calculator out and show you what happens graphing those. So if I go to y equals and substitute in the absolute value of x with minus 3 on the outside, so to do an absolute value in the calculator, you go math, arrow over to number, and it's number 1. Absolute value of x, arrow outside of that, and put minus 3. And then I'm going to come down here and I'm going to substitute in the absolute value of x minus 3 where it's all in the absolute value bracket. So I go to math, arrow over to number, enter, and put x minus 3 inside, like so. So that and that are this and this. And I hit zoom 6 to graph it around the origin. There's the first function, and there is the other one. So it's hard to see what's going on here. Hopefully this will let me write in it. So this function, no it doesn't. It's not letting me draw outside. Okay, so anyway, what's going on here is we have one function coming like so. That's this one. And then we have the other one, which is lower, coming down to here and then going like so. So they're riding on top of each other here. These values are shared to here. So here's the origin. So the absolute value of x minus 3 inside is a shift right 3 units. That's this one. And this one, absolute value of x with minus 3 on the outside of the absolute value function, is a shift down 3. So when our constant is within, it's a horizontal shift. And when it's outside, it's a vertical shift. So we would say the graph of y equals the absolute value of x minus 3 translates the graph of y equals the absolute value of x down 3 units, whereas the graph of y equals the absolute value of x minus 3 inclusive translates the graph of y equals the absolute value of x to the right 3. How do the values of g and h relate to the values of f? Okay, the input value for g, that's these up here. The input value for g has to be 3 more than the input value for f. That's the blue one. To get the same output value. And the input value for h has to be 2 less than the input value for f to get the same output value. So that's this one. So this one has to be 3 more, and this one has to be 2 less to get the same value of the parent function f of x. Okay, page 3 brings us to exercise 1. Exercise means do it yourself, so do this page, pause the video, come back, see how you did. And here we go. Carla and Isamar are disagreeing over which way the graph of the function g of x equals the absolute value of x plus 3 is translated relative to the graph of f of x equals the absolute value of x. That's the parent function, absolute value. Carla believes the graph of g is to the right of the graph of f. Isamar believes the graph is to the left. Who is correct? Use the coordinates of the vertex of f and g to support your explanation. So I will just show this with the calculator. I've already explained what number has to be put in here to make this 0. And the answer is -3. And the number that you plug in tells you the direction it should be shifted. So this is going to be shifted left 3. So to the left is the correct answer. So Isamar is correct. And so in the calculator, I have the absolute value of x, which is f of x, and I put g of x in y2, which is x plus 3. So if I go up and arrow over to the type of line and make that one thicker, okay, and then hit graph, there is the parent function, And the darker one is the absolute value of x plus 3. And you can clearly see it was shifted left 3 from f of x. So you say the graph of g is the graph of f translated to the left. The vertex of the graph of f is the point 0, 0, whereas the vertex of the graph of g is the point negative 3, 0, as you can see on my calculator to the left. Number 2, let f of x equal the absolute value of x, where x can be any real number. Write a formula for the function whose graph is a transformation of the graph of f given by the instructions below. Okay, so now they're trying to train us into figuring out what these are going to be. So a translation right 5 units. So let's just call them different things. So let's call this g of x equals. A translation right 5, left right is inside the absolute value bracket, and right 5 is going to be the opposite. So right 5 is going to be x minus 5. Okay, a translation down 3. So I'm going to call this h of x. Just, you can call it whatever you want, just not f of x. H of x equals the absolute value of x, and down 3 would be minus 3 outside. So whenever our change is outside, it's a vertical shift, but it's the same direction as the sign. So down is negative. Part C, a vertical scaling, a vertical stretch with a scale factor of 5. Okay, when we stretch, that means it's getting larger faster or smaller faster. So a scale factor, let's call this, I don't know, I don't like using I because that's a number in math. You'll see in Algebra 2. Let's see, I don't know, b of x. How about just b of x? B of x equals. So it's going to be an absolute value of x. Again, that would be the parent function, but to scale it up fast, to make it grow faster, you multiply it by 5. So it would be 5 absolute value, that almost looks like a 51x, 5 absolute value of x. All right, next one. Let's call it c of x. C of x equals a translation left 4 units. So we have an absolute value of x. Translation left is opposite. Left is negative on the number line, so we put a plus 4, and it's inside because, I almost put a parenthesis there. It's inside because left, right is inside, up, down is outside. All right, E. How about d of x equals a vertical scaling or shrink with a scale factor of 1/3. That's the same as a stretch. It's multiplication, but it's a number between 0 and 1, and 1/3 is between 0 and 1. So that'd be 1/3 the absolute value of x. So d of x is 1/3 the absolute value of x. Okay, page 4 brings us to going the other direction now. They're asking us to write a formula for a function depicted by the graph. So what I've done to help you out here is I've drawn the parent function f of x, where the vertex is at the origin 0, 0. And we're asking ourselves, what is the function of this red one that's over here 6 units to the left? So y equals the absolute value of x. Okay, and left, right is inside, so I left this space. Left 6, opposite of negative 6, is positive, so that would be the absolute value of x plus 6. Because if we put negative 6 in here, negative 6 plus 6 is 0, the absolute value of 0 is 0, so we have the point negative 6, 0. All right, part B. So now I'm going to move my parent function over to the origin. This would be the parent right here. Now this thing, a couple of things are happening. One, it's getting flipped. Whoops. It's getting flipped. So y equals negative absolute value of x. It's at the origin. The vertex has not moved, so there's nothing inside. And it is not shifted left or right, so there's nothing outside. But it's not going -1, -2, -3 over here, because watch when I rotate this. If I rotate this 180 degrees and bring it down, what is going on here? And I bring this down, let's try that again, to here, you see how it's not the same slope, if you will, it's not the same rate of change? Okay, so, whoops, I exploded it. There we go. All right, so the stretch has changed. It's narrower, so that's a multiple greater than 1. So there's got to be a number in here. So let me just move this. I got to leave a space. And so it's the absolute value of x, but we have a scale multiple in here. So if I see what's going on here, here's 1, 2, I'm looking for a point. Here's a point that's right at the corner. So that's the point 2, -4, and this is the point 2, -2. So when I plug in 2 to the parent function, I got -2, but in this one I get -4, so that's getting twice as big, twice as fast, so that is a 2 out front here. So when I put 2 in here, -2 times the absolute value of 2, which is 2 times -2, which is -4. So it is y equals -2 times the absolute value of x. And that looks like 21x. So let's just do this, and there it is. Okay, so now let's rotate this back to its original and bring it down to the origin here, just so you can see what's going on. These are parallel. It is growing the same speed, so there is no scale multiple out in front, but it is a shift left-right, so that is going to be an absolute value with a change inside. And it's moving over 1. Here's 1. Here's 2, so that's 1.5. So that would be 1.5, or and it's to the right, so it's minus. So it's minus 1.5 or 3/2. Okay, page 5 brings us to part D, and I brought in the parent function again. So here's the parent function. Up 1 over 1, up 1 over 1, up 1 over 1. Actually, it's up 1/2 over 1/2. But if I go up 2 over 2, it's on there. 4 to 6 is up 2 over to 2. So the slope is the same, so there is no scale multiple. So the absolute value goes here. It is a shift up 4 positive direction. So that's going to be outside the absolute value bracket. So y equals the absolute value of x plus 4. So if I substitute in 0, the absolute value of 0 is 0 plus 4 is 4. When x is 0, y is 4. Okay, the next one, let me move the parent down to here. That's f of x. Okay. Obviously, the vertex is in the same location, so it is not a vertical shift. It is not a horizontal shift, but it's increasing slower. So it is a scale of a fraction out front, so I know it's a fraction, and the absolute value of x is not shifted left, right, up, or down, so there's nothing inside or after like this one. This is not a minus sign, it's a fraction bar. We need a numerator and denominator because this is growing slower. It's less than 1 greater than 0. So this is the point. Here's 1 right here. This is 1 because this is a scale of 1/2, 1, 1.5, 2. And same down here. So we have the point right here is 4, 1. Up here, the same x gives us the point 4, 4. So 1 is 1/4 of 4, so that is our scale. Okay, number 4 says let f of x equal the absolute value of x, where x can be any real number. Write a formula for the function whose graph is described in the transformation of the graph of f. So let's just call this a of x since it's part A. A translation 2 units left and 4 units down. So I know there's something inside and I know there's something outside. 2 left, 4 down. Left is this way. The sign will be opposite, plus 2. Down, the sign outside is the same. So it's a of x equals the absolute value of x plus 2 with minus 4 outside. This moves it down 4, this moves it left 2. All right, b of x. 2.5 units to the right, 1 unit up. Again, we have something inside and out. 1 unit up would be plus 1. Inside would be right is negative, inside, opposite, remember? 2.5 units to the right, so it'd be 2.5. So b of x equals the absolute value of x minus 2.5, and then outside the absolute value bracket, plus 1. Okay, next one. C of x equals a vertical scaling with a scale factor of 1/2, and then a translation 3 units right. Scale factors go out in front, so 1/2. Absolute value of x, 3 units right is inside, opposite, and so it's 1/2 the absolute value of the quantity x minus 3. Okay, page 6 brings us to part D, continuing along here. So I'm going to say d of x equals a translation 5 units to the right. So I'm just going to put an absolute value bracket here with an x to start this off. Okay, 5 units to the right is minus 5 inside, 5 units right, opposite direction, and a vertical scaling by reflecting across the x-axis. A reflection gives us a negative sign, and a vertical scale of a factor of negative 2. So it's going to be minus 2. Absolute value, x minus 5. Okay, actually it should be a vertical scaling factor of 2. That's telling us the reflection right there. So they're telling us 2 times that there's a reflection. Okay, so number 5, write the formula for the function depicted by the graph. So again, I brought the parent function in, and here's the parent in blue at the origin with a slope of 1 and negative 1. And it was, so if I move this over, you'll see that the slopes are the same, which means that there is no scale. So there's nothing in front of the absolute value bracket. So I know there's an absolute value of x, but it was shifted left 2 and then down 4. Left 2 is opposite inside, so it's plus 2, down 4. So y equals the absolute value of x plus 2 minus 4. Okay, b, y equals, and now I brought the parent function down. So now if I move the parent function to here, we see that there is no scale change. Okay, it is not scaled, they're equal, the slopes are the same. So now we just have to determine the shift, the vertical and horizontal shift. Okay, so to go from the origin over, what did y change, x change? X went from 0 to here, so the distance from here to here, that's 5. So plus 5, right 5, and then down 2. So absolute value of x, right 5 is opposite, minus 5, and down 2 is negative 2. So it's the absolute value of x plus minus 5, and then outside minus 2. Okay. All right, here's part C. Alrighty then. Okay, look what's going on here. I do know it shifted to the left 4. As you see, I just moved that function from here to here, -4. But then it's reflected. I'm just going to rotate it real quick. Rotation, reflection, whatever. Okay, so that was rotated like so, and it lands right on top of it, which tells me there was no scaling. All right, so there's no number out in front, but flipping it makes it negative. Absolute value of x. Left shift is +4, and it's not shifted up or down, so there's our answer. Y equals the negative of the absolute value of x plus 4. Okay, here's page 7. I brought the parent function over with us, and so now what I'm going to do is move this over 3 and up 3, and it landed right on top, so there is no scale stretch. There's no stretch or shrink. There's no scaling, but it is moved right and up. So we went from 0 over to 3, and then we went from 0 up to, and this is the point 3, 2, 2.5, 3, 3.5, 4. So right 3, up 3 is going to give us the absolute value of x. Right 3's opposite, and up 3 is positive. So the y equals absolute value of x minus 3 plus 3. And if you're ever confused as to whether you have the right answer, plug in your x value of your vertex and check to see if you get the same y. So our x is 3, and we want 3 as an answer. So if I plug in 3 here, 3 minus 3 is 0. The absolute value of 0 is 0. 0 plus 3 is 3. So y equals 3. And we're at the point 3, 3. You can check that with all of yours that we just did, and you should. Okay, page 8 brings us to the end of lesson 18. Go to your problem set.